Okay, moving on to example number 3. This is a compound inequality. You can solve this in a couple different ways. How I like to solve this is work from the inside to the out. So I'm going to first take away a 1. And I'm going to take away a 1 in 3 places, okay? So the way I'm doing this is just keeping it like it is. I'm going to work from the inside to the outside, and I'm going to have to do 3 things every step. So I get a negative 1 is less than 2x, which is less than or equal to what? 4? Okay, at this point, we still have a negative 2, or excuse me, I don't know what I'm saying. We still have a 2 times the x in the middle. We got to get rid of the 2 by dividing both sides by 2. So now we have this. We have 1/2, we have less than, we have the x alone. That's our goal. Less than or equal to, and we have this being a 2. Okay, so we're finished solving this inequality. Hopefully that's not too difficult. Now we, from this point, should be able to graph this thing on a number line. So this is going to be what? Unshaded. And the 2 is going to be shaded. And you should understand why that's true. This is shaded because it contains the or equal to component. Because it's shaded means it does include the 2. Unshaded means it does not include whatever the number is. So in this case, it does not include the negative 1/2. And then from here, you should be able to come up with the correct what? The correct what? Interval notation. Ooh, interval notation. So negative 1/2, well, open parentheses, negative 1/2, comma, 2, closed bracket. All right. Moving on to number 4. This is a compound or type inequality. Just solve each of these inequalities as 2 separate entities. So we get x is what? Greater than, what do we get there? Greater than 1, or add 1 to both sides over here, or x is what? Less than, what's this? Negative 2 plus 1? Negative 1. Okay, so what does this thing look like graphically? Well, make sure you get it straight in terms of what goes first. This has to go first, okay? X less than negative 1. Negative 1 goes before 1. We're looking at a number line from left to right. Then put your 1 on there. Both of these inequalities do not include the or equal to component, so they're both unshaded circles. This one, x is less than negative 1, goes everywhere to the left. Less than, left. Greater than 1, pointing to the right, goes forever to the right. Okay, last thing, we should be able to now look at this graph, look at the graph, and translate it from the graphical form of the solution to the interval form of the solution. So let's do that. It's going forever to the left, so negative infinity to negative 1. Close parentheses. And then the u. The u. This is found in your CalcPad and WebAssign. Okay? Under sets, I believe. So make sure you find that. If you can't find this, then in WebAssign, you should use the comma like this. All right? But I think you should be able to find the u, and it should work out for you. If not, you please let me know. Okay? So 1, open parentheses, 1 comma what? Infinity. All right? This is technically how it should be written. Again, there's something called CalcPad and WebAssign. Just go through those different functions, and you should be able to find this U symbol. Do not just type in the letter U. That will not work. This is a symbol that means union with, okay? So find the symbol. Do not type in the letter U. Otherwise, it will not work. Okay, or I believe the comma will work as well. Okay, that takes care of those examples. Let's keep on moving. What about these nonlinear types? Well, these will require a little bit more time and effort, but hopefully they won't be too bad. So let's see what we can do with these. So this is already in factored form. If it wasn't in factored form, you need to factor it. All right, so what would the 2 zeros be? What would the 2 zeros be? If this just said the quantity 2x minus 5 times the quantity of x plus 3 is equal to 0, then wouldn't you end up with what? Wouldn't you end up with a positive 5/2 and a negative 3? Yes, you would. Now, look, here's the thing. in addition to it being or equal to, it's also saying it's greater than 0. So these are not the only solutions. These are two solutions, but there are actually infinitely many solutions, okay? Because you can keep dividing, real numbers in half, like to infinity. But anyway, here's what we're going to do. We're going to draw a number line, and we're going to put these zeros on our number line as they occur from left to right. And then what we're going to do is we're going to shade them in. And why are we shading them in? We're shading them in because of the or equal to component. Now, at this time, I'm going to divide this up into 3 distinct intervals, okay? So I have a first interval from negative infinity to negative 3, second from negative 3 to 5 halves, and the last interval from 5 halves to infinity. We got to figure out which interval or intervals actually make this inequality true. So let's come up with test values here. Let's come up with test values for x. So what about x equals negative 4? So a test value is any real number x that's located in any one of the given intervals. So do you agree that negative 4 is a number located on the first interval, negative infinity to negative 3? It is. Then maybe right here, test maybe 0. Because is 0 between negative 3 and 5 halves? Yes, it is. Stay with me. You'll see where I'm going with this. What about the last one? Maybe put in, 10. Is 10 greater than 5 halves? It is. So the next thing we're going to do is we're going to determine our sign. All right? Our sign, whether it's positive or negative, of each one of our 3 intervals. And all we're going to do to accomplish that is we're going to plug in our test value into every x in our original inequality. So you put in a negative 4 here, you get a negative 8 minus 5, that's negative 13, right? You plug in a negative 4 right there. I'm testing this value into my factors of my original inequality. Negative 4 times 2, negative 8 minus 5, negative 13. Okay, what's this one? Negative 4 plus 3 is negative 1. So what is that? You get a negative times a negative. All we care about is the resulting sign. A negative times a negative would be a positive sign. What about 0? You plug in a 0, well, you get negative 5 times a negative 3 if x is 0, right? What's a negative times a positive? It's a negative. You plug in a 10, you're going to get a positive times a positive, which is a positive. Okay, so that's just a quick sign analysis. At this point, all you do is look at the inequality symbol and understand it's greater than, okay? When is this product? When is the product of these two expressions greater than 0? Well, that's when you're looking at the plus. So graphically, those two intervals represent your solution. Okay, we want to be able to put this now in interval notation form. So the final solution would be from negative infinity to 3, close bracket, or open bracket, 5 halves to infinity. All right? That's the final result in interval notation form for number 1. Number 2. Number 2, you have options here. Let's just do it the same way I did the other one. So let's do x squared minus 4 is less than 0. There are different ways to do these, folks. I understand that. But the way I'm showing you will be helpful once you get to calculus when you run your first derivative test. But anywho, let's go ahead and do this. Let's go ahead and factor it. Okay, so we know that if it were equal to 0, our answers would be what? Our answers would be negative 2 and positive 2. So let's go ahead and put our number line down on our paper and put in the 2 zeros if it were an equation. So that would give you a what? Negative 2 and 2, and we're going to use open circles because of the inequality symbol, right? It's not allowed to be negative 2, not allowed to be 2, okay? Because it's just less than. All right, so let's come up with our test values. So maybe like a negative 3, maybe like a 0, and maybe like a positive 3, okay? And we're going to check to see what the sign would be equal to in each of these 3 intervals, all right? So if we plug in a negative 3 into these x's, what do we get? Negative 3, we get a negative 1, and then a negative 5. What's a negative times a negative? It's a positive. Good. Plug in a 0. What's a positive 2 times a negative 2? It's a negative. Plug in a 3, positive, positive, you get a positive. So there are your signs in each of the respective intervals. Now, look at the inequality symbols. Less than. So less than, that means 0. Less than 0, negative. Okay, less than 0 means negative. Greater than 0 means positive. So I'm going to go ahead and draw the graphical solution based on this inequality symbol. Now, I'm going to translate this inequality into interval notation form. So non-inclusive, non-inclusive, from -2 to 2. So the final result is the open interval from -2 to +2. Finished with example number 2.